Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve question number 38 of NEET Physics paper 2017. Students, let us solve question number 38. It says a long solenoid of diameter 0.1 meter has 2 times 10 raised to 4 turns per meter. That is the number of turns per length. At the center of this is our small n value. The small n is given by 2 into 10 raised to 4 turns per meter. And the length of the solenoid is okay, we'll write that first. At the center of solenoid, a coil of 100 turns and radius this is placed. So the situation is like this, that we have a solenoid like this. We have a solenoid whose diameter, that means this length is 0.1. The diameter is 0.1 meter and number of turns is given as this. At the center of this solenoid, a coil is placed. At the center, a coil is placed. This is a coil is placed at the center, having how many turns? The number of turns is n is equal to 100. And the radius of this radius, small r, say 0.01 meter is the radius of this coil, with its axis coinciding with the solenoid axis. So axis of both the coils are same. That means coils and the solenoid. The solenoid has springs and the coil is placed here. The axis of them are same. Current in the solenoid reduced at a constant rate of, so here the current that is entering I is reducing at the rate reduced to a constant rate to 0 from 4. So the current is decreasing from 4 to 0. 4 to 0 in time t equals to 0.05 seconds, and the resistance of the coil is having a resistance of 10 pi square ohm. So the resistance is also given as, 10 pi square ohms. The total charge flowing through the coil during this time, the charge flown, delta Q, is asked. The situation is that the solenoid, the current is reducing from 4 and it has to be 0 in 0.05 seconds. And during that time, the coil which is placed inside the solenoid having 100 turns there will be a change in the magnetic field through the coils, this coil. So because of the change in the magnetic field, there is a change in the flux associated with the coil placed inside the solenoid. When there is a change in flux associated with the coil, induced EMF will develop. When the induced EMF is developed here, then the charge will definitely flow, and we have to find that charge that is flowed. So let me just have to write that the EMF induced equals to minus N d phi over dt. d phi dt, this is the epsilon. The symbol actually stands for the EMF induced, and N is the number of turns, d phi over dt. This is the number of turns of the coil. If I think of the magnitude part, irrespective of which direction the current will flow, and E, if I divide R over here, the resistance of the coil, having N equals to 100 turns, E over R, if I take the magnitude on both sides, this becomes N over R d phi over dt. What I've done is I've divided R in both sides and taking the magnitude values. So this is the situation. E by R, we know that E equals to I into R. So the current that is this one. So this is the current, and the current is coming out to be N over R d phi over dt. And this current that is flowing in the coil is because there is a change in flux associated with this. And the current is basically the flow charge. So I'll say that the instantaneous current is dq or dt equals to N over R d phi over dt. So I'll write the dq, dt will cancel out. I'll write dq equals to N over R d phi. This is the situation I'm getting. This dq is the charge that very small charge that is flowing in the fraction of seconds. We have to find the total charge that is flowing during this time. So that means this formula can also be written as delta q equals to N over R and delta phi. This is the total flux. If I can find the total change in flux that is taking place, then I can find this delta q, the charge that is flown, the total charge. This is total, this is also total. This is one. So this T stands for the total charge that is flown, and this T stands for the total flux. This is phi stands for flux, phi for flux, and Q for charge. So this is the total flux changing, and this is the total charge that is flown, and we're asked to find the total charge flowing, that is Q delta QT during this time. So this delta Q can be obtained by, so this delta Q total is equal to N over R delta phi total. So what is the total change in flux? N total change in flux, that is initially it was starting, I could say 0. Finally it is 0 because there is no flux is 0, current is 0. So the change is involving phi equals to B dot A. This is the formula used. Flux, the magnetic flux. This magnetic flux is B dot A, which is BA cos of theta. Here the B and the in the same direction, so it is BA, and phi, if it has got n number terms, so NBA. This is the total flux. So I'll write N over R, okay, and this is for n number of turns for single coil, because I have already taken n number of turns, so only flux I will write BA, so it is NBA now because I have already multiplied n here. This one is the NBA upon R. Now I will have to write what is B for what is B that will pass through, what is the magnetic field that is passing through, because the flux is because of the magnetic field existing in the coil, and that is because that is a solenoid. So this coil is subjected to the magnetic field produced by the solenoid. So this is the magnetic field produced by a solenoid, and that is mu naught Ni. This is the, and that is the magnetic field which is also present inside the coil. So this B is nothing but, this is N by R, and the B is mu naught Ni into A. A is the area, which is pi R square, where R is the radius of that coil. Okay. So this is now, if I put the values, then this is I have to see the options first. The options are that during this time, the options are in microcoulomb. So N is 100, and divided by resistance, which is given as 100 pi square, 10 pi square, and mu naught actually pi microcoulomb, or this is mu is involved, that way to see. Mu naught upon 4 pi, we know that it is 10 to the power minus 7. So if I put that, then this is 4 pi 10 to the power minus 7. N is the number of turns per length, which was 2 10 to 4. So number of turns per unit length, it is 2 10 to 4. And mu naught Ni, this part is only because of the solenoid, and the rest part is because of the coil. So now pi is there, and mu naught N is this one, I mu naught Ni, so I is there, and R square is this radius square. The radius of that is 0.01, square is into 10 to the power minus 4. 0.01 is 1 upon 100, 10 to the power minus 2, square is minus 4. Now it is in microcoulomb. Pi is also there, so we'll see whether pi will be cancelled out, because this pi square here, pi and pi will cancel out. So the options either will be, it is 3 or it is 2. Now the current is changing, because this is the change that is we're talking about. This is not the flux, this is change. Change is current, is the change in current, I'll write, and this is a delta I, I'll write. The change in current is actually 4, so I'll write 4 here. because that's the change that is taking place. If I substitute that, then this 10, this is 100, this is 10 will be there. 1 0 cancels. This is 4, this is minus 7, 4, this is minus 3. This 2 is there. And this is minus 4 is there. Okay. And this I is there, obviously is 4. So now if I write, then this is coming out to be 10 raised to the power minus 7, 4. This is 10 to the power minus 2 because I'll cancel with this, 10 to the power minus 2. So it's minus 6, 4 to the 8 for the 32. So 32 into 10 raised to the power minus 6 coulomb, because that's the total charge flowing, and that equals to 32 microcoulomb. If I see the option, then option number 3 is correct. It is 32 microcoulomb. Okay, thank you.